In this presentation, we will talk about how to apply the binomial theorem to find terms in a binomial expansion. Let's define the binomial coefficients first. If n and r are integers greater than or equal to 0, with n being greater than or equal to r, then the binomial coefficient n choose r is given by the formula n factorial divided by r factorial times n minus r factorial. So let's find 9 choose 7. We plug into the formula for n equals 9 and r equals 7. So we divide n factorial by 7 factorial times 9 minus 7 factorial, which is 9 factorial divided by 7 factorial times 2 factorial. So remember, we don't have to write out 7 factorial because it's gonna cancel out with the denominator. So we just leave the numerator as 9, 8, 7 factorial. So when we cancel these terms out, we get 9 times 8 over 2, which is equal to 36. Here is the binomial theorem. If x plus y is raised to the nth power, this will give us a sum of n plus 1 terms, k changing from 0 to n, and each term consists of n choose k times x to the power n minus k times y to the power k. In the first term, we will have only x to the n. When we plug in k equals 0, n choose 0 will be 1, and x to the n minus 0 will just be x to the n, and y to the 0 will be just 1. Therefore, the first term will only have x to the n. And similarly, the last term will have n choose n, which is also 1, x to the power n minus n, which is x to the power 0, so no x exists in the last term, and we will have y to the power n. And you can see some of the in-between terms. We can also look at the pattern of each factor in each term. The power of x starts from n, in the next term it is n minus 1, and then it decreases to n minus 2, and so on, until the exponent becomes 0 and there is no x in the last term. Similarly, there is no y in the first term. In the second term, we have just y to the power 1, and the exponent increases to 2 until n. And also remember that n choose 0 and n choose n is 1, so the coefficients of the first and last terms are 1. Let's look at an example and write 2x minus 3y raised to the fourth power in expanded form. We use the binomial theorem. We plug in 4 for n, and instead of x, we put 2x, and instead of y, we put negative 3y. Let's find each term. I will look at the factors one by one. So let's start with the first factor, the binomial coefficient. So as k changes from 0 to 4, binomial coefficient will be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. The next one is the x factor. As k changes from 0 to 4, the exponent of 2x changes from 4 until 0. And the next factor is the y factor. When k changes from 0 to 4, the exponent of negative 3y changes from 0 to 4 as well. Next, we evaluate the binomial coefficients. So we find 4 choose 0 and 4 choose 4 to be 1. We find 4 choose 1 and 4 choose 3 to be 4. And we find 4 choose 2 to be 6. So we plug in these values. Then we simplify the powers of 2x. For example, 2x to the fourth power becomes 16x to the fourth, 2x to the third power becomes 8x cubed, and so on. And finally, we simplify the powers of negative 3y. Negative 3y to the zeroth power is 1, negative 3y to the first power is negative 3y, and so on. In the last step, we multiply out everything and get rid of the parentheses to simplify our results. Sometimes we don't have to find the whole expansion, but we are just interested in one of the terms in the expansion. So we can extract that term. Here is the formula. So the r plus first term is given by n choose r times x to the power n minus r times y to the r. So here is an example. Let's find the sixth term in the expansion of 3x plus 2 to the power 9. Because we are looking for the sixth term, r plus 1 given in the formula is 6, so we will use r equals 5 in our calculation. So we plug in n equals 9, r equals 5, and we put 3x instead of x and 2 instead of y in the formula, and we do our calculations, our simplifications, to find that the sixth term it's quite large, 326,592.